Bismillahirrahmanirrahim, my dear students. We'll meet again in the lectures of calculus 1 for the students of mathematics, Department of Mathematics, College of Science, Al-Majma'a University. Now we'll take a very important subject of the differentiability rules, which is the differentiation of the inverse trigonometric function. As we see, not all of the function could have an inverse, but for the function f of x to has an inverse, it should be a bijective mapping, which is to be one-to-one and onto injection and surjection mapping. Now for the differentiability of sine minus 1x, which is the inverse of the sine x, it will be 1 over 1 minus x squared under the root. d by dx for cosine minus 1x, it will be negative 1 over the root of 1 minus x squared. We notice that sine minus 1 and cosine minus 1 are the same except for the negative sign. Also d by dx for tan minus 1x, it will be 1 over 1 plus x squared. d by dx for cotan minus 1x, it will be negative 1 over 1 plus x squared. d by dx for sec minus 1x, it will be x multiplied by root x squared minus 1. d by dx for cosec minus 1x, it will be negative 1 over x root x squared minus 1. We note, for simplifying, keeping this in mind, it is positive, negative, positive, negative, positive, negative, alternating inside. Also, I will give you a very, very important technical way of how to deduce these rules if you forget it. But if instead of x it was u of x, we have to multiply the result by du by dx. For example, differentiate the following function. f of t equals 4 cosine minus 1t minus 10 tan minus 1t. The second question is y equal root z sine minus 1z. The answer. For the first question, d by dt for f of t will be as follows. 4, the differentiability of cosine minus 1 will be negative divided root 1 minus t squared. Also, the differentiability of tan minus 1t will be 10 over 1 plus t squared. For the second question, dy by dz will be as follows. The product of two functions. The first is root z multiplied by the derivative of the second, which will be 1 over root 1 minus z squared, plus the second will be sine minus 1z multiply the derivative of the first, which is root 1 over 2 the root multiplied by the derivative which inside the root. So it will be sine minus 1z divided by 2 root z. Now for the derivative of the hyperbolic function. We know now sine, the trigonometric functions, sine minus 1, the inverse trigonometric function. Now we have to find the hyperbolic function, which is the الدوال الزائدية. We will recognize what we call sine, cosine, tan, cotange, sec, cosec. What is the meaning of sine x? It means e to the power x minus e to the power negative x over 2. Cosine x, it will be e to the power x plus e to the power negative x divided 2 tangent x, it means sine x over cosine x. Cotangent x, it means 1 over tangent x. Sech, it means 1 over cosine. Cosech, it means 1 over sine. We are now interested by the derivative of sine x. D by dx sine x will be cosine x. The derivative of cosine will be sine. The derivative of tangent will be sech square. The derivative of cotangent will be negative cosech squared. The derivative of sech x will be negative sech x tangent x. The derivative of cosech x, it will be negative cosech x cotangent x. For example, differentiate each of the following functions. F of x equal 2x to the power 5 multiply cosine x. The second question, h of t will be sine t over t plus 1. The answer for the first question is that d by dx for f of x will be the product of two functions. The first function, 2x to the power 5, multiply the derivative of the second, which will be cosine will be sine. Note that the derivative of the first 3 will positive and the second 3 will be negative. Plus the second one, which will be cosine x, multiplied by the derivative of the first, which will be 10x to the power 4. For the second question, it is a fraction function, so that we have to apply the first rule of u over v. The denominator squared, which will be t plus 1 all to the power 2. In the numerator, we find the denominator, which will be t plus 1, multiplied by the derivative of the numerator, which will be cosine t, minus the numerator, which will be sine t, multiply the derivative of the denominator, which will be 1. We take the chain rule, but we have to remind us with it. If z equal f of y, while y f equal f of x, z is a function in y and y is a function of x, and we want to find the rate of change of z with respect to x, we have to say that dz by dx equal dz by dy multiplied by dy by dx. For this reason, if we have bracket to the power 17, for example, inside the bracket 5x cubed plus 12x squared plus 130, we can name all the terms inside the bracket by z. So y will be equal to z to the power 17, while z equal 5x cubed plus 12x squared plus 130. So dy by dx will be as follows: dy by dz multiplied by dz by dx. So it will be 17z to the power 16 multiply the derivative of z, which will be 15x squared plus 24x. Now we have to remove z and write instead its value. So it will be 17 multiply the bracket to the power 16, which is 5x cubed plus 12x squared plus 130 multiplied by 15x squared plus 24x. From this we conclude that d by dx to any bracket to the power n, it will be n multiplied by the bracket to the power n minus 1 multiplied by the differentiability of what's inside the bracket. So that directly, if we asked you to find d by dx for 12x squared plus 120 all to the power 50, so the derivative would be as follows: 50 multiplied by the bracket 12x squared plus 120 all to the power 49 multiplied by the derivative which inside the bracket, which will be 24x. d d by dx to f to the power n will be 50, the bracket to the power 49 multiplied what inside the bracket. If I asked you to find d by dx to sine 15x squared plus 20x plus 3, it will be cosine 15x squared plus 20x plus 3 multiplied by the differentiability of this bracket, which will be 30x plus 20. Use the chain rule to differentiate each of the following. R of z equal root 5z plus minus 8. F of x equal sine bracket 3x squared plus x. F of x equal 2x cubed plus cosine x all to the power 50. F of x equal e to the power x to the power 4 minus 3x squared plus 9. G of x equal ln x to the power negative 4 plus x to the power 4. F of x equals sec 1 minus 5x. F of x equal cosine to the power 4x plus cosine x to the power 4. For these tricky problems, we know the differentiability of the root 1 over 2 the root multiplied by the differentiability of what's inside the root. So r dash of z will be 1 over 2 root 5z minus 8, and in the numerator will be 5. The differentiability of number b, it will be cosine 3x squared plus x multiplied by 6x plus 1. The differentiability of c will be 50 multiplied by the bracket to the power 49 multiplied by the derivative what's inside the bracket, which will be 6x squared minus 9x. The differentiability of number d, it will be the same, e to the power x to the power 4 minus 3x squared plus 9 multiply the derivative of the power, which will be 4x cubed minus 6x. The differentiability of number e, g dash of x, will be 1 over x to the power negative 4 plus x to the power 4 multiplied by, in the numerator, negative 4x to the power negative 5 plus 4x cubed. I think all my students are familiar with this now. Now I'll give you a very technical way of how to remind yourself by the derivative of the inverse trigonometric function. If we want, for example, to find the derivative of d by dx sine minus 1 x. Let I'm writing with the mouse, I'm very sorry. Y equals sine minus 1 x. Then if we get sine to both sides, it will be sine y equals x, because the effect of sine on sine minus 1, the function decomposed itself, give me the element. We can now draw a right angle triangle with angle equal y. Sine equal opposite over hypotenuse. So the opposite will be 1 x and the hypotenuse will be 1. From Pythagoras we can get the adjacent, which will be the hypotenuse squared minus the opposite squared, which will be 1 minus x squared. But y equals sine minus 1x. We want to find dy by dx. So we have to differentiate this equation. D by dx to both sides. Get d by dx to both sides. If we get d by dx to both sides, we will get the following. The differentiability of sine will be right, cosine y. But we are differentiating with respect to x, it will be multiplied by right, dy by dx. Equals, the differentiability of x will be 1. That's right. So we want dy by dx. Divide over cosine y, so that dy, which we want by dx, will be equal to 1 over cosine y. But cosine y from this triangle will be right, adjacent over the hypotenuse. So it will be 1 over cosine with h, which is root 1 minus x squared. That's correct. You can find the derivative of any inverse trigonometric function by this way. Consider this inverse trigonometric function equal y. If it is sine, find sine to both sides. So sine y will be x. Draw the triangle. Differentiate with respect to x. Find dy by dx for the whole 6 inverse trigonometric function. Thank you for today. I hope I meet you inshallah in the next lecture. Assalamu alaikum wa rahmatullahi wa barakatuh.